Okay, so welcome to all of you. In the last lecture, so that means in the last video, we have seen some problems on the extreme value, right? So we continue the problems on the extreme value. So find the points on the cone z square is equal to x square plus y square that are close to the point 4 to 0. That means what we have to find the two points, or there may be 2, 3, 4 points. So on this cone, so this is a three-dimensional cone. So three-dimensional equation. Okay, so what we will do? We will take a point on this. Okay, so we will take a point P x y z or x1 y1 z1, and we will try to find the value of the x y z. Right. So we want the points. Okay, we don't want minimum distance. Okay, solution. Let P x y z be the point on the cone. So whatever this they said cone, they said is right, whatever this is, right? Don't bother about this name now. So on the cone z square is equal to x square plus y square, which is close to the point, I will say this is A 4 to 0. Okay, so then what we have to do? We have to minimize the distance between this P and A. So we'll find P and A. Okay, so P is equal to root of x minus 4 bracket square, y minus 2 bracket square, plus z minus 0 bracket square. Right? So we have z square is equal to x square plus y square. So, okay, so we'll write this d is equal to, we'll write this distance as d is equal to root of, now this is z square, right? So I have to convert this into two variable. So this is minus 2 bracket square. Your z square is what then? X square plus y square. Since z square is equal to x square plus y square. Okay, so I'll put that. Okay, now this is two variable function. We have to minimize this. So what we have to do then? We have to differentiate this with respect to x, equate it to 0. Differentiate this with respect to y, that means partial with respect to y, and equate to 0. Find the values of x and y so that your dx and dy is equal to 0. So once we get this the stationary point, the third point you can find with the help of z square is equal to x square plus y square. That means the third, this is what z you can find with the help of that equation. You get x and y. Okay. So now we will write dx now. So dx, this is what root of something is 1 upon 2 root of something. 2 root of x minus 4 bracket square, y minus 2 bracket square, plus x square plus y square into derivative of something. So into derivative of something I write in bracket. So this is what 2 into x minus 4 plus twice x. Right? So now dy, I find dy also. Again this is 1 upon 2 root of something, 1 upon 2 root of something, x minus 4 bracket square, y minus 2 bracket square, plus x square plus y square into derivative of this. So this is what 2 into y minus 2 plus twice y. Okay. So now we have to put dx is equal to 0 and dy is equal to 0. Okay. So I don't want this. So dx is equal to 0 and dy is equal to 0. Dx is equal to 0 and dy is equal to 0. That means this derivative we have to take the equal to 0. So that means what here, the derivative this is 0. That means your numerator is 0. Right? So directly you can write this numerator as what? This is twice x plus twice x. This is what? 4x minus 4 is equal to 0. And dy is equal to 0 means your numerator is 0 only. Right? So I take only the numerator. This is what? 4y minus 2 is equal to minus 4. Oh, this is minus 4. You have to multiply by this 2 now. This is what? Minus 8. This is minus 8. Okay. So 4x, this is what? Twice x minus 8 plus twice x. Twice x plus twice x is 4x, and this is minus 8. Okay. So that means x is equal to what? 4x is equal to 8 is what? 2. And y is equal to 4 now. Okay. So now you get x is equal to and y is equal to, right? So x is equal to 2, y is equal to 1. Right? So This is only we get only one stationary point, okay. So therefore x is equal to 2, y is equal to 1, z square is equal to 4 plus 1 is equal to 5, implies that z is equal to plus or minus root 5, right? So therefore p is equal to 2 1 root 5, or p is equal to 2 1 minus root 5 r and 1, okay. We'll write this as q, no problem for it. Are the points which are closer, which are close to, are the points on the cone, which are close to 8 4 2 0, okay. So the problem is over here, okay. So very simple problem, only you have to take the derivative. So which part is what? Root of something, you have to apply the root of something. So root of something or 1 upon 2 root of something into derivative of something, okay. So we'll take the next problem on the same format. Find three positive numbers whose sum is 100, whose sum is 100, and whose product is maximum, whose product is maximum. Okay, solution. Three positive numbers. Let x, y, z be three positive numbers. Whose sum is 100 and product is maximum. So that is x plus y plus z is equal to 100. I will call this as 1, okay. And p, I will call p as product, x plus x, y, z, okay. So I will do this in the two variable function, okay, because I want to apply the second derivative there, okay. So this is what x, y. What is z? 100 minus x minus y, okay. So I multiply this. This is what 100 xy minus x square y minus x y square, okay. This is your p. Now what you have to do, you have to maximize p. That means what? You have to find a stationary point such way that your delta is positive and a is negative, right? So that means what? We'll find px, we'll find py, and we'll equate to 0, and we'll find the values of x and y, okay. So now px, so px is equal to, okay, I will do it, okay. So px is what then? So this is 100y minus twice xy minus y square, okay. So now px is py is what? 100x minus x square minus twice xy. So what I do, I will put px is equal to 0 and py is equal to 0, okay. So for px I will take y common now here. I will take y common. So what we get then? Y 100 minus twice x minus y is equal to 0. I call this as 1. Then I will take for py, I will call this as 2 now, because 1 is already given, okay. Now I will take x common for py is equal to 0. So this is 100 minus x minus twice y is equal to 0. I call this as 3 now. Okay. So now here what? Y is equal to 0 and this is equal to 0, right? So y 1 or 2 implies y is equal to 0 or 100 minus twice x minus y is equal to 0. Okay. So 3 implies that. So x is equal to 0 or 100 minus x minus twice y is equal to 0. But your x, y, z are positive. That means they are not equal to 0. But x and y are positive. Therefore, they are not equal to 0. They are not equal to 0. That means what we have 100 minus. Therefore, we must have. Therefore, we must have. So what? This 100 minus twice x minus twice y. 100 minus twice x minus y is equal to 0. And 100 minus x minus twice y is equal to 0. I will call this as 4. I will call this as 5. Okay. So what I do? I will multiply by 2 for equation 5. For equation 2 now. This is what is 200 minus twice x minus 4x minus twice y is equal to 0. Then I will subtract this. Okay. I will subtract this. So what we will do? This is what minus 100. This is plus 3x. This is equal to 0. Okay. So that means what? X is equal to 100 by 3. X is equal to 100 by 3. So if you put x is equal to 100 by 3 in 4, so 4 implies that. So this is y is equal to what? Y is equal to 100 minus twice x. So 100 minus twice x means 200 by 3. So this is 300 minus 200. So this is 100 by 3. This is what? 100 by 3. So your x is equal to 100 by 3, y is 100 by 3. Right? So this is what? 100 by 3. 100 by 3 is a critical point. But we have only one critical point. So no need to check whether the function has maximum, minimum or whatever this. Okay. So we have only one critical point. Therefore, x is equal to 100 by 3, y is equal to 100 by 3, and z is equal to, what is z? Z is equal to what? So x plus y plus z is equal to 100, right? So 100 minus x minus y. So this is 100 minus 100 by 3 minus 100 by 3. So this is what? 300 minus 100. This is what? 200 by 3. 100 minus 200 by 3 is 100 by 3. 100 by 3. So therefore, the required three positive numbers are 100 by 3, 100 by 3, 100 by 100 by 3. Okay. So these are the three required numbers so that this product is maximum. Okay. We'll take one more problem. Find the maximum. Value of rectangular box that is inscribed in a sphere of radius of radius r, upper radius r. Okay, solution. So you have a box which is inscribed in a sphere. That means what? So you know that suppose this is a sphere. This is a sphere. And your box. So box is like this. So it is very difficult to draw this box here. Okay, so something like this. Something like this. Box is inscribed in the sphere. Okay, so it is very to draw the figure of this in 3 dimensions. Okay, so we'll just say what is for the box. There is height, right? There is height, length, and breadth of the box, right? That means x, y, z be the let x, y, z be the dimension of the box. Dimension of the box. Okay, which is inscribed in a sphere of radius r. Then what we have to do? Find the maximum volume of the rectangle. We want a maximum volume of the rectangular. So what is the volume of the rectangular? X, y, z. X, y, z is the volume of the rectangular. So now since equation of the sphere is what? X square plus y square plus z square is equal to r square. Okay. So now the diagonal of the box, the box is diameter of the sphere. Diameter of the sphere. Okay. So therefore we have x square plus y square plus z square is equal to 4r square. 4r square. Okay. So this is equal to what then? V is equal to x, y. Your z is what then? Root of 4r square minus x square minus y square minus r square. Okay. Now what we have to do? Find the maximum. We have to maximize this. Okay. So we'll find Vx and Vy will equal to 0 and we'll find the value of x, y, z. X, y, z, so that we get a maximum value. So you want maximum value. So Vx is equal to. So you have to apply the product rule here. Okay. So x, y as it is. Into derivative of this 1 upon 2 root of x 2 root of 4r square minus x square minus y square into twice x plus 1 upon root as it is now 4r square minus x square minus not this is 1 upon root as it is root of 4r square minus x square minus y square into derivative of xy is y now. Into derivative of xy is y. Okay. So now, so this is what then we'll simplify this. So this is what your 2 get cancelled. This is x square y. This is x square y. Okay. Then we have to do the product of this one. This is what then plus y into 4r square minus x square minus y square upon root of 4r square minus x square minus y square. Okay. So we'll find Vy now. we will find y. Again we have to apply the product rule here, because this is xy, that is the function of. So I take xy as it is, 1 upon 2 root of 4r square minus x square minus y square into minus twice y. Oh, here minus. Here we get minus. Okay, so I write in bracket. This is minus twice x, because derivative is minus twice x. Okay, so minus twice y plus root of 4r square minus x square minus y square into x now. Derivative of x y partial with respect to x. Okay, so this is what then minus. So 2 can cancel here. xy square plus x into, we have to take the square of this one, r square minus x square minus y square upon root of 4x square minus x square minus y square. Okay, so we have to put vx is equal to 0 and vx is equal to 0 and vy is equal to 0. Okay, so now here what? Here y common, you can take here what? X you can common. So y common. What we get there? Minus x square plus 4 r square minus x square. So minus x square minus y square is equal to 0. And I can take x common here. So this is what? Minus y square plus 4 r square minus x square minus y square is equal to 0. Okay, so x and y cannot be 0 because they are the length of the box, right? So then they are the length of the boxes, that means what? Cannot be 0. So that means what? Here then 4r square minus twice x square minus y square is equal to 0. And so this is what? 4r square minus x square minus 2y square is equal to 0. You have to solve these two equations simultaneously. So what we get? So this is what? Simply this is x square. I multiply by these two now here. So this is what? 8r square. Okay, minus twice x square minus 4y square is equal to 0. So what will do? I will subtract this. What? Minus plus. So this is what? 4r square minus 4r square. Okay, your 2x twice x square cancel. So this is plus 3y square is equal to 0. So 4r square will be there. Then is what? Y square is equal to 4r square by 3. 4r square by 3. Okay, so if you put y square in this equation, you will find the value of x square is also 4r square by 3 x square. Okay, now note that. So x and y are positive, so we are taking the positive root, right? So therefore x is equal to 2r by root 3. Y is equal to 2r by root 3. Okay, this is your x, y. You need to find z now. Okay, so your z, how you can find z? Okay, so we get only this, right? So twice r by 3, twice r by root 3 is only one critical point. So therefore we must have x is equal to twice r by root 3, y is equal to twice r by root 3, and you can find the value of z. So with the help of that, root of this one. Okay, so z is equal to, so your z is equal to root of what? 4r square minus x square what? 4r square by 3. 4r square by 3 is equal to root of. So this is what? This is 8 4r square minus this is what? 8r square by 3. So this is what? Root of this is 12. So this is 4r square by 3. So this is 2r by 3. We will take the positive value 2r by 3, right? So therefore x is equal to 2r by root 3, y is equal to 2r by root 3, z is equal to 2r by root 3, right? So you want maximum value. Maximum value is equal to x, y, z. So this is what? Twice r by root 3, twice r by root 3, twice r by root 3. Okay. So now this is what then 2, 2, 2. This is what? 8 r cube by 3 root 3. Cubic unit. Cubic unit. R unit cube. Whatever this. So we take the next problem and then we will solve. We'll take one more problem. Okay. So find the dimension of the box with volume 1000 centimeter cube, that has minimal surface area. Okay, solution. Now see, so you have to find a box, right? So this is your box. This is your box. Okay, so what we will do? We'll say this is y with the height, this is what x with the length, z with the height. Okay, so and y with the breadth of the this. Okay, so let x be the length, y be the breadth, and z be the height of the box. Okay, so then what we do is dimension of with volume, and so volume of the box. Volume of the box is what? This is a rectangular box, right? So this is what then x, y, z is the volume of the box. You are given that this is what? 1000 centimeter cube. Obviously your x, y, z are also in centimeter. Okay. So now your z will be what? 1000 upon xy. Whenever we will convert this in 3 dimension. Okay. So now we have to find the surface area of the box. Okay. Is it in the open top? Is not even in the open top. Okay. So not even in the open top. That means what? You have to. There are 6 surfaces. There are 6 surfaces of the box. Okay. So now we find the surface area of the box. Surface area of the box. Now there are 6 surfaces. We'll add all the surfaces. See, this is the what? This is the bottom surfaces, right? So this is a rectangular box. That means what here? This is a rectangle, x and y. Okay. So now what is the area of the rectangle? You know that length into the product of the length is nothing but the area of the rectangle, right? So the bottom area is what? X into y. So this is the rectangular box. That means top is also the area of the top is also xy. So this xy plus xy. So this will what? Twice xy. This is twice xy plus. Now we'll see the side of the box, right? For the side. So for this side, what we get then? This is what? Your y and z. The length of the rectangles are what? Y and z. This is also same now. This, right? So that means what? This is zy. This is what? Twice zy. Now see from the front side of this box. So your this front side is what? This. The length of the rectangle is what? X and z. The dimension of this rectangle are x and z. Now this same side and back side, right? They are also same. That means their surface area is also same. So the surface area for the front box, rectangle is nothing but what? Xz. Front side of the box is nothing but xz, and from the back side of the box is nothing but also xz. So this is twice xz plus twice xz. Okay. So I will write this surface area as S now, and I will convert this in terms of the two variable, I will replace z as 10, 100 by xy. This is what? Twice xy plus 2y as it is. Your z is what? 1000. This is not 100. This is 1000 upon xy plus twice x as it is. Twice x as it is. Your z is what? 1000 upon xy. So this is equal to twice xy plus, so this was 2 into 2000, your y get cancelled, so 2000 upon x plus again your 2 get x get cancelled, this is 2000 upon y. Okay, now we get a two variable function. What we do, we differentiate with respect to partial with respect to x and partial with respect to y, will equal to 0 and we will find the values of x and y. You get a critical point, and with the second derivative test we will find this one. Well, if you get a single critical point, then no need to do that, right? So that is what your surface area should be minimum, because what we want the paper sheet to make a box. So we are always trying to use the minimum material, right? So with the help of the minimum material, you have to make a box so that the volume of the box is maximum. That is what 1000 square, 1000 centimeter cube. Okay. So we'll find a Sx now. Sx is what? Twice y. So because derivative of 1 upon x is minus, right? So minus 2000 upon x square. Okay. And Sy, we differentiate this with respect to y. So this is twice x minus 2000 upon y square. Okay. So we equate this equal to 0 now. Equate it to 0. So Sx is equal to 0 and Sy is equal to 0. Implies that. So if you put this is what? Twice y is equal to 200,000 upon x square, and twice x is equal to 2000 upon y square. Okay. So now this is what? Y is equal to 1000 upon x square. X is equal to 1000 upon y square. So I put the value of x is here now. So I put the value of y here. So x is equal to 1000 upon your value of y. I will put the value of y here. This is what? 1000 upon x square bracket square. Right? So now this will be x cube now, right? So this is x is equal to x cube upon, this is 1000 square, so it get cancelled, 1000. Okay. So now I will shift 1000 to that side. So what happened is 1000 is equal to x cube. Okay. 1000 is equal to x to the power 4, not x cube. This is x to the power 4. X to the power 4. Now since what? X not equal to 0. Since x not equal to 0, this implies that 1000 is equal to x cube. So this implies that 10 is equal to x. Your x is 10. So if you put x is equal to 10, this implies that y is equal to. This implies that we have to put y here, because with the help of this y, I get the value of x. So I will put y, I will put x to find the value of y. I will put x here now. I use this equation to find the value of y. Because of this y, you get the value of x. So that means what, you have to find the value of y from this equation. Don't find the value of y from this equation, because what, with the help of this equation, with the help of this y, you are putting this y here now, right? So we get x now. So if you want to find the value of y, right, with the help of x, so you have to apply, you have to use this equation to find the value of y here. So this is what, then this is 100, your 10 square is 100. So again this is y is also 10, right? Y is 10. So therefore 10 is a critical point. Is a critical point. We have only one critical point. We have only one critical point. Critical point. Okay. So therefore x is equal to 10, y is equal to 10. So what about z then? So your z is what? What is value of z? So your z is what? Z is equal to what? 1000 upon xy. So again this is 10. Again, this is 10. So what answer you want? Find the dimension of the box, right? So therefore dimension of the box, therefore dimension of the box are 10 centimeter, 10 centimeter, 10 centimeter. That is what? It is a cube. It is a cube of, length 10 centimeter. All sides are same. It is therefore it is a cube. Okay. So I hope that you understand all these things, right? So how to find the critical points. Okay. So we'll stop here. Okay. So thank you.